Most digital tokens are summoned into existence with a few lines of code. Developers type out a maximum supply and deploy it to a network. Because this process relies entirely on human instruction, the resulting assets are weightless. They carry no embedded cost and require zero physical effort to generate. In the physical world, creating matter or extracting resources demands massive expenditures of energy and mass. There, everything must follow the laws of thermodynamics. Without that physical grounding, digital value depends entirely on a founder's preference. It is a social contract rather than a structural reality. Bitcoin functions as a continuous thermodynamic engine. Every 10 minutes, endless rows of industrial hardware consume terawatt-hours of electricity to secure a single block of data. This raw, real-world energy is converted into a permanent record, transforming electricity into unalterable information. Because this data is secured by an immense physical commitment, it behaves differently than a standard database entry. It possesses digital mass. Bitcoin provides a digital space bound by verifiable physical constraints, creating a substrate that cannot be forged, duplicated, or erased. Digital matter theory, or DMT, treats this permanent information as a distinct state of matter. A Bitcoin block contains immutable data fields like block height, transaction hashes, and nonces. Under DMT, developers identify patterns within this structural data. These digital objects inherit the network's permanence. They cannot be altered because they are part of the ledger itself. This framework moves blockchain development away from the subjective invention of tokens and toward the objective discovery of digital substances. Developers use a digital periodic table to categorize these substances, mapping block properties instead of chemical elements. Just as the periodic table provided a map to find gold or silicon in nature, this digital map allows builders to locate structural materials already hidden in the blockchain. Bitmap was the first major discovery on this map. It takes block height data and translates chronological history into persistent spatial coordinates. By mapping block history into a grid, Bitmap demonstrates that Bitcoin's timeline is actually navigable digital real estate. While Bitmap provides the space, the non-arbitrary token, or NAT, serves as the economic element discovered within it. A NAT supply is not chosen by a team. It is strictly derived from the block's bits field, meaning token issuance is tied directly to the thermodynamic difficulty of the mining process. For individual artifacts, the framework uses UNATs, unique non-arbitrary tokens, to generate traits without human bias. Traits are pulled from the most chaotic variables in a block, such as the miner's knots, removing the developer's hand from the art generation. NATs and UNATs achieve thermodynamic scarcity, where every characteristic is born from network physics rather than human choice. Extracting these digital materials creates a new economic layer for the mining industry. Because NATs are generated from block data, miners receive these assets as a secondary subsidy just for operating their hardware. This creates a feedback loop. As traditional block rewards decrease, the value found in digital matter provides the revenue needed to maintain hash power. DMT establishes a secure system that pays for Bitcoin's future security without requiring a single change to its core code. Weightless, arbitrary tokens are being replaced by digital assets with true structural mass. Bitcoin has developed a language for digital substance. Things with a verifiable origin, an embedded, mathematically proven rarity, and unyielding, immutable network rules. They exist regardless of market price. The NAT token is the first element identified on a digital periodic table that is still mostly blank. These unyielding laws of physics are now building a vast digital landscape, one as permanent as the chain itself.